All right, so let's do 2 more examples from 7-3. So if you're given the sine of 90 minus x is equal to square root of 3 over 2, find the length of segment AB. All right, so some SAT type work here. It's a right triangle. If angle C is x degrees, then the measure of angle A has to be 90 minus x degrees. Okay, because we know the 3 angles in a right triangle have to add up to 180. If the measure of angle B is already 90 degrees, then A and C have to be complementary. So our piece of information is really just saying the sine of angle A is equal to the square root of 3 over 2. Okay, so what's my sine function? My sine function is opposite over hypotenuse. So from angle A, opposite side is square root of 3 over 2. Excuse me, opposite side is square root of 3. Hypotenuse is equal to 2. All right, well, in the figure, the hypotenuse is actually equal to 8. So where does that figure in? So let's use, if the hypotenuse is 8, then I would have to multiply my ratio by 4. So 4 root 3 is actually going to be the length of BC if 8 is the length of the hypotenuse. So all that we did, the given ratio was completely simplified. The hypotenuse had a length of 8. So when I look at this, well, 8 can't equal 2. What do I have to do to it? I have to multiply it by 4. But if I multiply that side by 4, I'm going to have to multiply my other side by 4. All right, so now if I'm looking for the length of AB, well then what can I do? I have 2 sides of a right triangle. Now I can use the Pythagorean theorem. You have to bear with me a little bit. My screen is not cooperating. Okay, so the length of AB squared plus 4 root 3 squared has to equal my hypotenuse squared. All right, that's our Pythagorean theorem. So I have AB squared plus, please be careful when you square this. You have to square the 4 and you have to square the square root of 3, which just becomes 3. Okay, so AB squared plus 48 equals 64. Okay, so when we go to, we get, AB squared is equal to 16. So the length of AB would be equal to 4. Okay, next example. This one's a little bit harder, and we'll continue to come back to problems like this over and over. And I please encourage you, in the files, I copied the entire section 7.3, which has more examples in the book. Please look those over as you're trying to do these. All right, so if the sine of theta is equal to negative 5/13, find the cosine of theta. All right, so let's think about a couple things here. First, what's my relationship for my sine function? So the sine function is always associated with the y coordinate. So my sine of theta is equal to y over my radius. Cosine of theta is equal to x over my radius. Okay. So if I'm given y and r, I can find x using the equation of a circle. X squared plus y squared equals r squared. So one thing to note, and this will be true throughout everything, my radius always has to be positive. Okay, depending on where I am in what quadrant, we talked about your x and your y values being able to be negative. In your second quadrant, x is negative, y is positive. In your third, both coordinates are negative. And in our fourth quadrant, x is positive, y is negative. X and y can be negative. Think that they show direction for us. Your radius always has to be positive. Okay, so I'm going to fill in what I know. X I'm looking for because that's going to allow me to find my cosine. Y is equal to negative 5. R is equal to positive 13. Okay, so 25 equals 169. X squared is equal to 144. Taking the square root, don't forget you get 2 answers. Okay, and that's going to be important. All right, so now let's think of where the sine function is negative. So my sine function is negative wherever my y-coordinate is negative. So when I look on my unit circle, I could be in either quadrant 3 or quadrant 4, because in both of those quadrants, my y-coordinate is negative. So what that means for us, depending on what quadrant we're in, the cosine value is going to be either positive or negative. So in quadrant 3, I'm going to have both my x value and my y value be negative. In quadrant 4, my x value has to be positive, my y value remains negative. That's the significance of our plus or minus. So when I'm in quadrant 3, my radius is 13, my x-coordinate is negative 12. In quadrant 4, my x-coordinate is positive 12. So when I go to answer the question to find the cosine of theta, well, there's two answers that exist. The cosine of theta can be negative 12 over, we've already established our radius is 13. In quadrant 4, my cosine is going to be positive 12 over 13. Okay, so there's two possible answers to this because the sine function can be negative in two quadrants. Now, we'll look at more specific problems where it'll say the angle is, say, only in quadrant 3, find the cosine function. Then we would only take the appropriate value, whether it being positive or negative. But for right now, you're expected to find both cosine ratios. Okay, I'm just going to finish those examples here. I'll post these, and then as you're working, I can always do additional examples as needed.